So let's do a little bit of revision, obviously to do with our lesson today. We're starting with graphs, okay? The main topic is graphs, and today we'll be talking about how we interpret graphs. Okay, so let's get started. We're gonna start with revision. What is this picture that you see on the screen right now? What do you call this thing? What do we call it? How is the snow? It's gone. Linear, not quite. What do you call this device where we draw graphs, guys? The one with numbers and it's like two number lines that are crossed. What do we call the whole thing? There's one word that there we go. Thank you, Mutare. We call it a Cartesian plane. This has everything to do with our graphs, right? At least you tried, Simon. Okay, Santrushka. Everyone else is just quiet. Everyone here is just spectator ions. I see you guys. I see you guys. Come on. There's very few of us, so we're gonna have to like talk more and stuff. Come on, guys. So this is a Cartesian plane. And just to remind ourselves and each other, it has two axes. The y-axis, which is this one, which would have y on it. So y-axis. And of course, the x-axis, which goes horizontally. And then we have quite literally two number lines, right? Going up on your y-axis, you have the positive numbers, and down you have the negative. And going to the left of your x-axis, you have your negative numbers. And to the right, we have our positive numbers. Now, all these dots you see here, we call those points, okay? Now, the way in which we draw graphs is to plot a bunch of points, and then we join them. Now, it doesn't help if we want to know how to draw graphs, but we don't know how to plot points. So I'm going to see if we remember how to find and write coordinates from a graph. Let's start with A. What are the coordinates of A? For those who can't see A, it is on the y-axis over here, the purple one. How do we find coordinates? Does anyone remember? And how do we write coordinates? There's a specific way to write coordinates that will help me find what you are talking about. Now let's see if anyone remembers this. We did this. Bridget says the coordinate is 1 and 0, but is it written completely correctly? Bridget? Santrushka says it's 0 and 1. Okay, the other way around. And this time they are written correctly because they are my brackets. Tando says 1 and 0, but Tando used the comma. Then there we go. Sia says 1 and 0. It's okay. We need to remind ourselves, right? So we are between 1 and 0 and 0 and 1. Firstly, I need to remind us how we write coordinates. So you have to first open your bracket, which I see some of you guys are still leaving out. Open your brackets, your y-x coordinates, excuse me, the semicolon, and your y coordinates, and you close your brackets. This is this is the only acceptable way, guys, for me to know that what you're writing in the chat are coordinates. Now let's see. First, we're gonna look for the x coordinate. Now, if it is on the y-axis, then the x coordinate has to be what? It has to be 0, guys. It is not 0 at y because it is quite literally on the 1. Can you see that? So then the y coordinate would be 1. And so my coordinates are 0, 1, not 1, 0. Do we get it? See, a lot of you guys said 1, 0, but do you understand why it can't be 1, 0? It is on the y-axis, which means your x coordinate is 0. Okay, let me name this. This is A. Okay, now that we've reminded each other how to find coordinates, what is the coordinates of B? What are the coordinates of B? Remember x first, semicolon y, and of course your brackets. So I'm going to write my brackets in and my semicolon already. I'm going to wait for you guys to remind me, or to tell me rather, what the coordinates of B are. Anyone? Come on, guys, let's not be shy. Yes, Sia. Sia, it's here.
Hi, ma'am. Hello.
Hi. Yes, I can hear you.
Ma'am, the coordinates will be as brackets 0 semicolon 1.
But those are the coordinates of A. Do you see that?
But
Is the
for B,
X1 or is the Y1? Look where B is. Is the X coordinate one?
Oh, the X is 1.
There we go. So it has to be first the 1 and then the
Y is 0.
there we go. There we go, guys. We're getting somewhere. Okay, let's do like one more and then we're moving on to 2 days work. Tell me, guys, what are the coordinates of D? What are the coordinates of D?
E is 4 brackets 4 and -3 semicolon -3.
Okay, C has told us E, 4 and -3. Thank you very much. That would be correct for E. And then for last thing, what I asked for was D. So let's hear what D has to say. Not what D has to say. Who's D, guys? Let's hear what you guys have to say for D. The cold is freezing my brain as well. That's what I'm going to blame here. Tano says -3 and -1. I like how you guys are remembering to put your X first. That would be correct. So open bracket, -3, -1, close your brackets, and that would be D. Great, so now we know how to plot points, and I'm sure we would know, we know how to find them, and I'm sure we would know how to plot them. Now let's get to today's work, okay? Now we're gonna talk about types of graphs. First, we're gonna talk about linear and non-linear graphs. How do we know that we have a linear graph? Okay, so linear graphs have a constant difference. Does this sound familiar? This sounds like something we've done before, right? Constant difference. Where have you heard the word constant difference before? Where have we heard the word constant difference before? Do we remember? Anyone? Kamahela says, yes, it sounds familiar. Anyone remember where we've heard it before? Okay, I'll wait for you guys to tell me as I read the rest of the definition. Between the terms, which causes a linear pattern. Yes, which topic specifically, Sia? And that means it will make a straight line. There we go, Tando. Number patterns. That's where we've heard constant difference before. So then we would know how to find the constant difference, right? We've just learned how to plot points. So that means if I give you a graph like this, you guys can draw a table, write down your inputs and outputs, and then look for the constant difference. That was beautiful. Thank you very much. Okay, so if your graphs looks like so, it's a straight line graph. There is a constant difference between the terms. Let's see if there is a constant difference between this one. Okay. Okay, this is going to be a little bit difficult. We'll check at the bottom. I just realized why it's going to be difficult to find a constant difference here. But that would be a linear graph. Okay, so that means if I give you a graph or a table, you must be able to identify whether it's linear or non-linear. So in a table, you look for constant difference, and in a graph, you look for the straight line. Simple and straightforward, okay? And non-linear would be graphs that do not have a constant difference, and the rate of change changes between the terms. Okay, that was very complicated, but the way it changes is different. We'll talk more about this when we talk about the gradient. It's coming up. Next lessons, we're going to talk about gradient. That will be the rate of change is different. Okay, that will cause the graph to curve and change in direction. So if you have a table and it does not have a constant difference, or if you have a graph that curves or changes direction, that would be a non-linear graph. I think those are pretty simple and straightforward to understand. Okay. Now, let's talk about the following. Are the following graphs linear or non-linear? Let's hear what you guys have to say. This is a graph that shows us the distance traveled by a car in seconds. Okay, so at 0 seconds, the car has traveled 0. It hasn't moved. That makes sense, right? At 5 seconds, it has traveled 50. 50 meters, maybe, definitely not kilometers, right? And then 10 seconds, it's at 200. 15 seconds, it's at 450. 20 seconds, we are at 800. So what do you guys think? Is this a linear or non-linear graph? Tanda says linear. There are 23 of us in here. I'm expecting way more answers than one. Lita says, I can't even see the graph. Kamukelo says linear. Tepang says non-linear. Interesting. Sia also says non-linear. We are 2 for 2. Okay, now we are 4 for. Ooh, this is tough. This is tough. Anyone feeling brave enough to tell me why they say it is a linear or non-linear graph? Anyone? The car is moving fast. It is. It is moving fast. It's important for us to not interpret graphs, right? But that's because it's accelerating. Think about it. When you take off from a stop sign, you start off a bit slowly, but then you go faster and faster and faster, right? So anyone feeling brave enough to tell me why they say non-linear or why they say linear? Anyone? Nobody wants to tell me. Voltaire said, because it is going up, so it is moving to a higher point. It is going up, but does that make it a linear graph? Let's remind each other what linear graphs are again. How do I identify linear graphs? Kamukelo says, because it is curving up. Did Kamukelo say it's linear or non-linear? I don't remember. Kamukelo said linear. Okay. Because it forms a pattern. I'm guessing Bukhia said it was linear as well. Why is nobody that's saying non-linear saying something? Come on, guys. Sia, Tabang, those are all the people that said non-linear. Hey, Sia has said something very important. It's okay, Samkelo, welcome. Sia has said something very important. Linear means it is a straight line. Yes, Tepang also said non-linear, remember. Let's look at those graphs carefully, guys. Is this a straight line? Our definition said it either has to have a constant difference or it has to have a straight line. Exactly. So this can't be a linear graph, right? And let's even check our constant difference. We could even use our constant difference, guys. Let's see. We are at 0, 5, 10, and 15. Okay, at 0, we were still at 0, right? At 5, we were at 50. What's happening with my handwriting? Nobody knows. Even me, I don't know, guys. This is what happens when I don't see this for weeks. Okay, at 10, we have 200. And at 15, we're all the way at 450. Now, to get from 0 to 50, guys, how much did we add? How much did we add? Kamkhal is laughing at my handwriting. It's fine. To go from 0 to 50, how much do we add, guys? How much did we go up by? Yes, yeah, 50. And then from 50 to 200, how much did we go up by? So 50 to 200, we went up by 150, 200 to 450. 50, 150, 200 to 450, guys. How much did we go up by? 250. Now, is this a constant difference, guys? Remember, constant difference means you add the same thing every time. Are we adding the same thing? No. First, we added 50, and then we added 150, and then we added 250. See, it's going up exponentially. It's going up more than constantly. It's not constant at all. So that means this cannot be a linear graph. So you can check in both ways for yourself. Okay. So therefore, what is our conclusion? This would be non-linear. Are we with me, guys? I haven't had a check-in so far. Are we with me? There we go. So the direction of the graph doesn't matter. So whether it's going up or down or straight or what, but you need to look carefully if it's a straight line or if it has a constant difference. Okay, so now I showed you two ways to check. Now let's go to our next one. Is this graph a linear graph? Is this a linear graph? Or rather, is it linear or non-linear? Let me say it like that. Welcome, Sia. It's okay. Do we have a linear or non-linear graph? Sia says linear. Okay, everyone says linear. Okay, give me two reasons. This is a linear. Okay, give me one reason. Give me not be two. Give me one reason that this is a linear graph. It is straight, simple and straightforward. So here we have a linear graph. Beautiful, beautiful, guys. See? Okay, let's move on. Is this a linear or non-linear graph? Do we have a linear or non-linear graph? Kateko says non-linear, Bridget says non-linear. Let's hear what everyone else has to say. Kamukhela says linear. Okay, we'll do. Novisa says non-linear. What does everyone else say? There's nearly 30 of us in here. I'm expecting way more answers. Oh, non-linear. Non-linear. Some girl says non-linear. Question mark? I don't know. Maybe, could be. Mushe says non-linear. Sia Tanda says non-linear. Oh, Gamukhelo says linear. Tanda says non. Oh, so since so many of us said non-linear, please give me a reason why this is a non-linear graph. Give me a reason. You could give me two, but I only want one. Oh, Ngateko said such a beautiful reason. That is such a beautiful reason. Because it is changing the direction. Exactly, guys. It is not a straight line because it is changing direction. Okay, so from July to August, it went up. August to September, we changed direction. September to October, we changed direction again. So another way we can check, as we know, is to check the common difference. That's why I included these graphs. I know that these graphs would generally trick a lot of people. Okay, exactly, it changes direction. So this is not linear, okay? This would not be considered as a linear graph, all right, because it changes direction. If you are ever not sure, just check your difference. Okay, let's check July. From July to August to September to October. Okay, so in July, how many cars did we sell? 25. Okay, we sold 25. In August, we sold 30. In September, only 15. I wonder what was happening in September. And in October, 35. Okay, so from 25 to 30, what's the difference there? What's the difference? Exactly. We added 5 from 25 to 30, right? 30 to 15, are we adding? When we go from 30 to 15, we're not even adding anymore. We are subtracting 15. Then from 15 to 35, we're going back up and we're adding 20. See, it's going up and down and up and down and up and down. So this is definitely not a constant difference, right? So if you're not sure, if you look at a graph and you're not quite sure, then check some points that are consecutive. Do we remember what the word consecutive means? Do you remember what consecutive means? Anyone? Let's see if we remember this. Nope. You need to check points that are right next to each other, okay? You can't compare July to September and say that you are adding 15. No, that's not allowed. You need to check ones that are right next to each other. That's why I go from July to August or to September, September to October. Okay, you can't go from July to September and then go from August to October and say, oh, we're adding 5. That means it is lit. No, okay? So you can check by adding consecutive terms and seeing if they have a constant difference, and that is how you will know. So our conclusion here is this is non-linear. Beautiful. I hope we're all doing good still. Okay, let's move on. Now we have a table. Nobody freak out. Nobody freak out. We know how to check if a graph is non-linear or if it is linear. So tell me from this table, so this is the number of packets we have sold and how much we made from selling those packets of chips. I'm going to just assume this is chips now. Okay, so tell me, is this table a linear or non-linear function? Okay, we call them functions because it's technically graph, not, yeah, we call them functions. Jeez, I don't know where I was going with that. English was like, nope, peace out, I'm done. Okay, I see everyone saying non-linear. Nkateko says linear. Let's hear from everyone else. Let's hear from everyone else. Ma'am, so if the constant difference is not the same, it becomes non-linear, yes. Because then it's not constant. Then it's just a difference, okay? Remember, difference means you subtract 2 points and see what the difference is between them. So if you're not adding the same thing everywhere, or you're not subtracting the same thing everywhere, then it is, yeah. Let's hear, guys, non-linear. Kamkhalu's like, tap out. Mkateko is the only one who said linear, okay? Mkateko, do you want to tell us why you said this is a linear function? What makes you think this is linear? Guys, we must always think about the conditions that make something linear, right? Then decide from there whether it is linear or non-linear. Bridget also says non-linear. Mkateko, do you want to tell us why it's linear? Oh, no, I just told you guys the answer. That was terrible. Because the numbers are adding up. I don't know. Guys, what are conditions? Remind me of the 2 conditions. How do we know that functions are linear? First one is the graph would be a straight line. We don't have a graph in this case, right? But there's a second condition that we are all not thinking about right now. What's my second condition, guys? Constant difference. Is there a constant difference? Let's check points that are right next to each other. How do you get from 35 to 70? How do you get from 35 to 70? What do we add to get from 35 to 70? We're adding 35. Yes. Okay. What do we add to go from 70 to 105? So from 70 to 105, you guys said from there to there, we have to add from there to there, we're adding 35 again. 105 to 140. Your brain is like, nope, it's too much for me. 105 to 140. Look carefully, Kamukelo. How much are we adding from 105 to 140? 35. What's going on here? What do we have, guys? What do we have? We have a constant difference. So I'm going to ask again, is this a linear function? Constant, oh my gosh, I need to change where I sit so that my handwriting doesn't look the way it does. Constant Difference. There we go. See, guys, so this is linear. I am hoping I didn't lose anyone on the way. This would be linear. Okay, are we good, guys? Are we good? Before we go to a brain break, I need to check on you guys. Are we all good? Is anyone lost? Thumbs up, thumbs down. Are we all still with me? Okay, I see some thumbs up in the reactions. Some girl says, yeah, all right. Okay, so there are no thumbs down. So we're gonna move on to a brain break. Brain break. You guys are making me sound like I'm so evil. Like I can't
I
even.
think they haven't had a brain break in maybe 3 weeks. So
Whoop.
they're very happy right now. I can tell you that much.
It's been too long. We're celebrating for a brain break. Hectic. Okay, we're gonna play Would You Rather. And as always, okay, I have interesting questions. Would you rather have to eat with your belly button or drink with your ears? In weird fashion, in my weird fashion, of course, my questions are going to be strange. Would you rather have to eat with your belly button or drink with your ears? Eat with your belly. Oh, Kamukelo. Oh, Kamukelo's hand vanished. Everyone says belly button. What's going on? Come on, let me hear someone's voice. Yo, some girls like yo, belly button. Belly button. I heard that your belly button was your old mouth. Bridget, can you imagine trying to eat a burger with your belly button? I can't. I actually can't. Yes, listen. Would you rather eat with your belly button or drink with your ears? A whole burger with your belly button, guys. Please think about this carefully. Wet ears, guys. That is way too a lot. You're just drinking with it.
It's either wet ears or a dirty belly button. So like, I don't know. And I suppose if you're drinking from your ears, you can just carry a straw with you everywhere you go, and then
Exactly.
like the straw in.
Just carry a straw, guys. You guys. That is not having it. That is not having this thing of drinking with your ears. Like, no, guys, belly button. What's wrong with y'all? Imagine eating in public with your feet. You must lift your shirts and stuff things in there and make sure they can fit. So you must cut them in pieces. Ew. Yes, Kamukelo. So many. Hi, guys. Just use a straw, Lisady. What are you guys drinking that's chunky that's gonna block your ears? Okay, let's go down. Would you rather sound like a cow or a chicken when you laugh? Would you rather moo like a cow or cluck like a chicken when you laugh? Do you remember that show? So, Mama had a chicken, Mama had a cow. Daddy was proud, he didn't care how. A lot of people are saying cow. You guys would rather moo. Guys, can you think of the people around you and their confusion? At least with the chicken, they'll sort of know you're laughing. Like at least with the chicken, people know you're laughing. If you start mooing, people will be like, what's up with him? Are you okay? Imagine mooing in a meeting. let's just be serious now, guys. Imagine mooing in a meeting. Like, I can't even, you guys are not thinking about vision and mission here. Next one, would you rather have tiny feet and huge hands or huge feet and tiny hands? Let's hear what you have to say. Huge feet, tiny feet, big hands, I can carry stuff. How you gonna walk with that stuff, Kamkhelo? I think, guys, please think about your balance when you have tiny feet. Like, let's think about this, guys. Tando?
Hello, ma'am.
Hello.
Ma'am, if I'm being honest, having huge hands is better because you'll be able to walk with your hand. You'll be able to use your hands to move around. And if someone annoys you, you can just beat them with your hands.
Hectic. Guys, I don't promote violence. Please. Yay. Guys, Tana said you can walk with your hands. I'm so traumatized. Like, I can't even, like, I don't know. Imagine me size 90. I'm done with you guys. I'm actually done with you guys. I'm finished. I'm completely finished. Okay. Would you rather shave all your hair or lose all your teeth? Guys, when we say shave all your hair, we mean eyebrows as well. Okay, let me clarify. Eyebrows and eyelashes as well, like everything. They're like, nah, I don't lose my teeth. Lose my teeth, shave hair. So even your eyebrows, guys, I could rather have nothing there.
Yes, I would rather have no hair whatsoever than have no teeth. How am I gonna eat? What am I gonna do?
I actually can't. Simone, think of your eyebrows. Please think carefully.
You see, my eyebrows are very easily replaced with a pencil. So I can always grow it in. I can stick on eyelashes, but what am I gonna do with teeth?
Where are you gonna stick your eyelashes if you don't have one to stick on? Like, where? Please think about this. You can't just stick on in the edge. They must sit on something. Guys, come on, guys. Come on.
I'm not eat. No ways. Have you ever seen an old person eating that has no teeth? It's the grossest thing. Oh.
You guys are mean. I love old people. Okay, whoever sees this, I love old people. I don't endorse Simone's message. Let's check the last one. Would you rather always drink from a massive bucket or a baby bottle? Always drink from a huge bucket or from a baby bottle? Let's hear what Kamogelo has to say. Kamogelo. Yes, Kamogelo. People who are saying baby bottle, please think about when you're really thirsty. Like you just played a sports match and you really need water. You guys are willing to risk your lives. Hey. Hi, Ty.
Hi, ma'am. I'm just saying, wouldn't it make more sense to drink from a baby bottle because you don't know where the bucket has been?
You don't know where the bottle has been. Maybe it's your personal
No,
bucket that you're walking around with. I don't know.
no, but what if you found the bucket in Soweto?
Then that would be your choice. Me, I'll get a new clean buckets. And you guys, you know the thirst of gym? But you must drink from a baby bottle. When we say baby bottle, guys, we mean you must screw on the top. Like that one hole is the only one that you have. That little bit of water that's coming out, that's where you must drink from. You guys are gonna die, I'm telling you. Imagine.
Miss Cat, are you prepared to carry around a big bucket full of
I'd rather, ma'am. They have handles. I'd rather. Do you know those
No.
baby bottles? The liquid is so slow. You can just like.
Imagine you're walking in the
just
middle of
wait.
the mall and you're like just there with your bucket of water.
Imagine playing sports and they're like, half time. Now your team must wait for you. Anyways, I'm sorry. Please think about your lives, guys. Do you know first? Imagine at night, you know, when you wake up at night, guys, and you've been dreaming, you don't even know where you are. You know those sleeps where you wake up and you're like, hey, where am I? And you are very thirsty, like you're dying. But you have to drink from a beer bottle. Just think about your lives, guys, please. No, you're not allowed to open the lid, Voltaire. That's what I said. Don't bite anything. The way it is, guys. The way the baby bottle, you guys chose the baby bottle. There's someone drinking from a baby bottle. I'm kidding. Looked very tiny though. Okay. There is your brain break that you've been bothering people with. And now we're going on to some work again. Now we're going to talk about increasing, decreasing, and constant graphs. Now let's read our definitions. Everybody come back to the lesson. Baby bottle people, please stop it. See, it's the problem ones are the baby bottle people. Those are the problem. Look at the chat. The bucket people are waiting for increasing function. Look at CRA, bucket, increasing function. When the relationship between x-axis and y-axis are in direct proportion, which means when x increases, y increases, then the graph will be an increasing graph, okay? So when you look at the graph from left to right, it goes upwards. I think that makes sense, right? If it goes downwards, remember from left to right, then that would be a decreasing functions. That would mean that the relationship between the x and y axis are in indirect or inverse proportion, right? And then you have a constant where one of your values remains the same. It's either the x value or the y value. In that case, you will have a straight line graph. So it'll go either horizontally straight or vertically straight. Those are constant functions, okay? So let's work on distinguishing between increasing, decreasing, and constant functions. Let's see. Okay. So hours away from shuttle and gas required. So if you're going to be traveling 5 hours, you're going to need 3 kilograms of gas. Okay, we see? That's what this graph is telling us. So I want you guys to tell me, is this an increasing, a decreasing, or a constant graph? What is it, guys? Some girl says increasing. Some girl says constant. We have a bit more increasing. Okay, this is easy enough to tell, right? So we look from left to right, as if you're looking from your 0 going on to right. As I said, when you were at 2, if you want to do this using points, you can as well. From 2 to 4 to 6, right? So at 2, we needed about how much? Maybe 2.5. It's 2.5 hours a day, sorry. Then at 4, we are up to maybe 7.5. And then at 6, we are up to just after 10. So maybe 11. These points are increasing, guys, right? And remember the proportion. They said when one increases, the other increases. Let's look at the gas required in kgs. 2, 4, 6. Is that increasing or decreasing? That will be increasing, right? And then you look at the hours away. 2.5, 7.5, 11. That's also increasing. So if both variables are going up or both are going down, no, never mind. Yeah, both are going down. It can work that way. Then this would be a increasing graph. Remember what I said about points? You're going to have to be able to identify it without a graph. Hint, hint. Okay, let's see here. Reproduction of bacterial cells. Okay, now is this an increasing, a decreasing, or a constant graph? Let's hear what we have to say. The reproduction of bacterial cells. Kamugelos is increasing. Swangalushas is increasing. See what everyone has to say. It's just over 30 of us in here. Okay, we're all saying increasing, right? So now we all know how to identify it. So this would be an increasing graph, right? Now I'm going to go back and say, is this a linear or a non-linear graph? Is this linear or non-linear? It's increasing, but is it linear or non-linear? Let's see. Non-linear, great. I just wanted you guys to see that these properties are not necessarily dependent on one another. So a graph can be increasing and non-linear, or increasing and linear, right? So the shape of the graph tells you whether it is in a linear or non-linear, but the direction tells you whether it is increasing or decreasing or constant. Okay, let's see, what else do we have here? Okay, now we have a table. I love tables, guys. I love tables. So in your opinion, in this table that we have over here, would this function be an increasing, a decreasing, or a constant? Let's get back to the lesson. It's an increasing function, okay. What does everyone have to say? Lita also says increasing. Some Samkelo says increasing. Question marks. Tepang and Siamtanda say increasing. How do you guys know it's increasing? How do you guys know whether it's increasing? Let's hear. Let's hear if we know or if we're guessing. It is indeed increasing. Is there anyone who can tell me why they say it is an increasing function? This is indeed increasing. Because it's moving from negative to positive. Okay, I think what you meant is they're both going up, which would be correct. Kamahelo. You look at your x variables, it's -2, -1, 0, 1, 2. They're going up, as you said, going from negative to positive, right? And if you look at the y's, you have to look at both. It's going to be -8, -6, -4, -2, 0, 2, 4. That was also increasing. So they are, well, it is indeed an increasing function because both variables are increasing. Remember, both have to be increasing, okay? Both have to be increasing. Okay, now let's look at these two graphs. Would you say these are increasing, decreasing, or constant graphs? Both of them. These are two separate graphs. Increasing, decreasing, or constant? Spongule said the integers were increasing. That was a good answer. Spongule, I just saw it now. Okay, let's start with this one. It says x is 1 throughout the line. So if you get the coordinates of there, it's 1, 3. If you move a bit lower, the coordinates is 1, 0. If you move a bit lower, the coordinates is 1, negative 3. So what's remaining constant, guys? What is remaining constant? Can you see the coordinates? What do the coordinates have in common? Exactly, the 1. Thank you, Vultari. So if the 1 is not changing, that means wherever you go on this graph, x will be 1 because x does not change. Do you see, guys? So this is what the graph would look like. Yes, Muthle, that would be a constant graph because one of the coordinates does not change. If you look at the second one as well, this time which one is staying the same? Is it the x or the y coordinates? Yes, Nkateko, and that would be the y coordinate. Can you see that? So no matter where you go, thank you, Tando, no matter where you go on this graph, the y coordinate will be 3. Exactly. So that graph is called y equals 3 because no matter where you go, no matter where you go, the coordinate of y will be 3. Okay, so these two would be constant graphs. So constant graph can either go horizontally, that's when your y doesn't change. Can you see that here? The y remains 3, 3, 3, right? So that will be a horizontal constant graph, and a vertical one is when your x doesn't change. 1, 1, 1. Okay, we're with me. Let's do one challenge and then we can all go. When are the following graphs increasing, decreasing, or constant? I hope we're ready. Okay. When are the following graphs increasing, decreasing, or constant? So yes, we can have graphs that look like this. They are increasing, decreasing, and constant. Who can tell me when they are increasing? When is this graph increasing? From where to where? Okay, Sepang says from Thursday to Friday. Is that the only time this graph is increasing? Spongobusha says Monday to Wednesday, and then Thursday to Friday. Yes, guys, that is when the graph would be increasing because it is going up. If you look from left to right, the graph is going up. So increasing would be, let's check again. You said from Monday to Wednesday, then again from Thursday to Friday. Wonderful. When is the graph decreasing? When is the graph decreasing? Wednesday to Thursday. Okay, so that would be Wednesday to Thursday. And when is the graph constant? When is my graph constant? Friday to Sunday. And then final question, is this a linear graph? Is this a linear graph? Spongobusha says no. Let's hear what everyone else has to say. Is this a linear graph? No. Okay, tell me why. Tell me why you guys are saying this is not a linear graph. Give me one reason why this is not linear. Let's see. It is changing direction. Woo, you guys are so fabulous. That would conclude our lesson for today. Okay, if you're wondering why I'm in the dark, it's switching. It is changing there. Yes, Kamcha. That's why I trick you, so that I can't trick you again. You see, guys, like I have to trick you once so that nobody can trick you after I tricked you. Vision and mission, guys. Okay, that will conclude our lesson, guys. Thank you for joining me.